Recording to start. Okay. Hello and welcome to etcd community meeting. Today we have August 25th and we have 3 topics on our agenda. And let's start with the first one from Hayes or Hayes to
Hi.
Roman. Yeah.
Hey, thanks, Marek. Nice to meet you. Hi, all. So my name is Hari, and I'm working for Microsoft. So this is the first time I'm meeting you. So basically, I'm evaluating a key value store for our use in Azure Cloud. So as you all know, the consistency and scale are important. So right now, I'm looking into HCD. I was doing a code walkthrough to understand certain things and got into this observation. So I thought, let me get it confirmed from the HCD experts. So I did this code walkthrough in 3.4, and I also see that this it remains the same in even in the 3.5 code. So so in summary, what I'm trying to say is like when the user calls put key value, so which lands in the HCD server. So what I observe here is that the entry is sent across other routines. One writes to val, another one, updates the batch transaction, and that batch transaction regularly flushes the data to the database file. So what I see here is so let's say you do this Linux scheduler, right, which can basically reschedule a running thread back to the put it back in the runnable queue. So having said so all these things, right? So I first probably my fundamental question is basically if these writes can occur in any order. That is something I would like to know. And yeah, so let me know if that makes sense.
Can you just repeat what is the right question? Is etcd say? Yeah, could you maybe just repeat the question?
Yeah. So okay. So let me put it this way. No, when the user does a put HCDCTL put with a key value, so the acknowledgement, the OK acknowledgement comes, right? And what I see is there's a possibility that the user sees OK, but the write to val and writing to the database file can happen a little late due to the if the Linux scheduler puts those routines the back of the runnable queue, right? So which means those writes can occur in any order. So if that is the case, for instance, even before the write can happen.
Okay. Because I'm reading the issue, are you talking about because there are different places that you pointed out that there is, possible, or let's say we exit too early, or there's a chance that the thread, the write is done asynchronously, or
Yeah.
just a certain, some writes in etcd are done asynchronously. Is it an error? So to give you short example why it's not always an error, you here pointed out to the commit function. Let me maybe. So I cannot give you guarantee that there is no strange race, but if you talk about transaction commit, this is database part of etcd, and etcd doesn't guarantees that the things will land in database, because it does the persistence of etcd is not done during database, or during normal requests. Requests can be flashed, can be done asynchronously to the database. What is important that the entry is in raft log or wall log. So first etcd writes that there was a change in database, so it saves diffs, and and updates the in-memory state, and the flashes to the disk can be done later.
Yeah. So this I see. So if you see even for the val, right? So even the val commit, right, can also happen let's say if it also gets delayed to get executed, and what I see is the user can see okay by the time. So the user sees okay, but there is a possibility that the val entry has not yet done.
What I mean, I would need to see it to
So I might also add that I think this should be used in the 3-node cluster. I think it's really important to reproduce in the 3-node because there is the sort of message confirmations going on in Raft, right? So the 1-node cluster, it won't really. So in a 3-node cluster, right? So the writer has to, or the leader has to send to at least one more node and get the confirmation from that node to really send the okay back to the user. And that's sort of that's a Raft protocol. So basically, what you're saying is that the this is kind of violates, if this is true, this sort of violates the Raft protocol, basically. So there is a possibility of data loss in a cluster. So I think that will directly violate the Raft protocol. So it's like, okay, or there's a bug in etcd that causes this, or the Raft protocol is wrong, but which, let's say, that's not true, right? So I think you should, bottom line, you should try to reproduce it in the 3-node cluster, because 1-node clusters, they like just more for testing, in my opinion, and not about like achieving the.
I mean, so the issue should be reproducible in 1-node cluster, because what, if I understand correctly, the issue that is brought up is fact that node is promising to Raft or responding to Raft before it really persisted data to the disk. So in that way, the Raft would respond, okay, the data is persisted because majority of the nodes have persisted it.
Well, I think technically though, well, maybe I can look into this more. I'm not 100% sure, but ideally, we shouldn't even allow to start a cluster that has a 1 node, right? Because that's not enough for us to do its thing, right?
I mean, it makes that. This is other topic. I feel it's like Raft assumes that when the entry is applied or committed, or the member responds that it's committed, it's persisted to the disk. So this should be reproducible no matter the size of the cluster. And it's even easier to reproduce it on the size of the cluster because you can go in with debugger. So I would say one cluster node you should also, like, assuming that the Raft implementation is correct, you should reproduce this issue in one cluster node, and that doesn't matter the. I mean, like, I think that we go into details of how to reproduce it. I just need, what I would want to have is minimal reproduce steps. So to give you an example, I mean, you've sent some examples here of, oh, let's modify the code or like some exit now. etcd has a failure injection framework. I would recommend to, like, if you want to inject failures in a way that you will understand, I would recommend trying to use this. You can send a request. You don't need to operate on file. You can send a curl request, and it should be that one thing. And there was a recent issue that and Was it this one or okay? So I would recommend. I know. I would love to see a script or something that shows that there is an issue. I mean, I'm not saying that it's not possible. It's just hard to comprehend how to reproduce this.
Okay.
Like, I cannot I click the PR and someone I don't know how to reproduce based on the link.
Sure.
Another option, if Benjamin is still looking into this, but I can also just try to reproduce what you posted, and then I'm actually curious if what you said, whether I still think it's like we need to do Sereno cluster, but maybe I'm wrong. But I can give it a shot and post my conclusion if that, and then maybe if you can find some other way to reproduce it using the testing framework is also great, but it might be difficult because what we're doing is kind of shutting down the etcd in a certain moments of time kind of.
I mean, so this is why I recommend the failure go fail. So you create a or you add the test case or you first add the fail point using go fail, then you add a test and maybe end-to-end tests where you just use the fail point and execute it, and you show that the test fails.
Okay.
That would be this is I'm not saying this you will. So at the end, when we find the issue, I would want to have something like this to prove that we resolved the original problem. So if assuming that we inject failures, we can reproduce that the failure no longer happens in testing. So like regression testing, we would add a regression test. So the main thing, I would definitely not look into bbolt because, like mentioned before, bbolt, assuming, so the only assumption, the bbolt transaction needs to be atomic, but if the transactions are atomic, it's whatever fail in committing to the database should never result in data loss because the data should be already preserved in WAL. The only edge case with atomic is when the consistency index is not synchronized to or the changes were not committed with the consistency index. So that would be the only case that database can cause, let's say, data loss because it assumes that the data was already up or that the WAL entry was already applied when it was not.
Yeah, and so that is pretty much so. So what I observed is basically the database flow is kicked in, and then the val writing is kicking in. So what I did is I locally tried to reorder in a way that I persisted the val entry and then pass that entry to the necessary routine, which is basically we ordered two statements so that the val write happens first and then the entry is sent to the database flow. So with that, when I tried the same exit now thing, so I was properly, the HCDCTL was properly throwing the error saying that it has failed. I never saw that any okay with that. So yeah, so that I wanted to bring in. So which I thought that will be I was basically thinking that shouldn't we put the val first and then the rest of the flow starts.
I mean, if I'm not sure, I'm just saying that I haven't, maybe I haven't looked into wall code enough, but I assume that we always persist to wall. If you can show, because you didn't show the line with the wall, so if you can show me I can also research it, but if you can just give an example of where you think, where is the bug, because with the wall saving, with the wall.
Yeah. So let me try to show it. So probably should I share my the
I
screen?
mean, we have still 3 topics on our agenda. I think if you can add it to if you can explain what is your reproduction steps and how you did it. I mean, I wanted to give an example of other issue that was recently posted, but this one. So, like, this is good example. Give us a script that executes this. Like, this is a minimal reproduction of the issue, and it showed that there is an issue in etcd, and I already reproduced it and confirmed it within 2 hours.
Okay. So I'll also look into this. At the same time, I'll also post the screenshot of the code, the val code, which basically kicks in the database flow and then the val save. I hope that should also give some information. Yeah, that's all from my side. Thanks.
Okay. Okay, we have still 11 minutes, so let's maybe speed up. I hope that we will speed up a little.
Yeah, I'm very sorry for taking the time.
We have Andre. Do you want to bring your topic?
Hello, yes, I have just questions, no bug. First one is about SSD disk with volatile write cache. For example, there is DRAM and no battery, and file system is mounted with no barrier. It means that actually data will be in write cache, but it's not going to land on real disk media. But fsync will finish with awk. So in this case, if the power loss will happen on one node, how etcd cluster will behave? Will it detect the bad node? What could be the worst case? What could be the best case?
I mean, we can only, I assume no one tested it before, or at least no one wants to take chance to answer it.
I haven't tested it, but I think you're gonna abide by Raft protocol guarantees. So basically, what you're saying is that one node confirms so fsync works. One node confirms the write, but it actually can still fail, right? Kind of that's
exactly. So the fsync confirms that wall is written, but then sudden power off will happen with disk, and we will lose this because it was in cache actually, and it will happen only on one node in cluster. Let's say we have 7 nodes cluster, and only one node will get this issue. So what may happen? Will we detect it because revision ID will be different, or maybe revision ID will be okay, but data will be corrupted, and during read, when you will read the data later, maybe you can understand that, okay, data is different and Raft algorithm will prevent it. I don't know. I also never tested. Our hardware team recommended us to use no barrier, but I'm a little bit skeptical about it.
I think if you maybe use the reads with the reusability, or basically that it asks other nodes for the during the read, then I would imagine this should be avoided. I think it's hard. I think again we need probably more better scenario, and then if you can like specify like more precise scenario to answer this, and maybe if you sort of look at the Raft paper, or you know, and say that, okay, how about this case? So that will be easier to answer, because I think this is a little bit maybe too abstract. Anyway.
I mean, I would need to. I cannot, like, we can answer theoretically, but until you have really tested it, cannot, like, there is no straight answer. In principle, as long as fsync runs and there is no half-written pages, so let's say so all the data is atomically saved to the disk, or the wall is persisted. I think it should work, but
Yeah, the case is exactly opposite. The etcd will get OK from fsync. So fsync will tell you that data is written, but actually that data is not written, and it, let's assume, it's just one node. So how whole cluster will detect it? Yeah, it's
I mean, you can always guess that this node gets correct, assuming that. So pages can be written in any order. I would need to ask a couple of questions. Pages. So let's say there is no. This file system responds that data is saved, but there is no guarantee that it's saved. So let's say random pages are saved on the disk. I would assume it will break the Diebold B-tree implementation, because you could say that, let's say the pages that change the B-tree root were saved, but the other data was not saved. That would mean that the state of the database is not correct. So at the moment that this member becomes the leader, it will tell other members what to do, and they will try, and for example, will send let's say the other member restarted, and it will get the snapshot from the broken leader. So you cannot guarantee that this member never becomes the leader and then copies its incorrect state to the other members. You would need to have some guarantee that this member, I mean, why would you, so I assume this is exactly the same case that you would expect that this member gets corrupted, has the data corrupted. And because etcd doesn't have any method to detect corruption, this member could I mean, not detect corruption, I mean disk corruption, so single member. I mean, I assume it would not work. Based on what you said.
Do you have any documentation about disk corruption case which you just mentioned, or any issues which I can?
May I also comment a little bit? So I think I was just looking at the Raft. So this might fall into the category of so-called Byzantine failures, right? So Raft doesn't work in that case, right? So basically, the nodes have to trust the leader, and this seems to be the situation where that's like a Byzantine failure. So I would look into that direction. I think this falls in that category.
I mean, as a general class, unreliable fsync is not a Byzantine failure. It happens in all kinds of situations. And I guess, and obviously any database is going to have a limited ability to recover from hardware-based failures effectively. Most code tends to focus on detecting them as early as possible to limit the amount of corruption.
Yeah, so etcd has methods to detect corruption, but based on based on experience, they work, but they are not still fully reliable. So I would look into the how do you call it? Corruption detection flags. But I would still guess that this gives you some window to detect if there was a real corruption, but you still are under the problem of you could serve like invalid data. Okay. And does it answer your question, Andre?
Yes, at least I have some reading. I can read about Byzantine failure, about corruption detection flag.
Okay. Do you want to follow on the second?
Second is pretty easy. There is a metric with name, I don't remember name. If you click the issue, there is last comment. It's also just a question, not issue. The metric name in last comment is something RTT round trip. Yes, etcd network peer round trip time second bucket, and it gives me 700 milliseconds, which 5,000 times more than its actual round trip reported by ping. My question is, the metric from etcd counts disk latency, or it's pure network metric?
I would recommend read the documentation, like with the documentation. I don't think I can answer it without reading resources.
If you step through the problem, you can probably figure out what it's doing. I would recommend just doing that. Like if you're running it, you'll get the answers, I think.
Oh, okay. So, I mean,
the etcd because that's appended.
Yeah, appended.
And even maybe network.
Yeah, this is the great thing about Prometheus. You can never find the metric that you're looking. Okay, so if you scrape the metric, it's easier to sometimes to scrape the metric using curl and get the metadata about the metric and documentation. I cannot that would be, it's basically someone needs to look up in the code, and I think it's not something that you remember. I usually also we can look how the metric is used by how someone uses the metric, but yeah, we have just a graph. Someone defines a graph on the metric, so I don't know. Okay. Yeah, exactly. Thanks for linking the metric. Yeah, it doesn't even answer so I would look at the code based on that. Sorry for being great. Greta, is the topic, do you think is your question pass?
Yeah, should be easy. I think the answer will be offline, but I wanted to raise this. There has been some work on Bboth side, which should enable us to lift this 8 GB quota. Seems like it is waiting on passing some tests. So what tests do we use to qualify this is my question. Maybe someone can comment on this CR to, I can take those up if I get some clarity on what needs to be tested.
I guess benchmark, so I think the original, how it was originally stated, it was based on bottlenecks, which means that there is no, let's say, large regression when we go from 8 GB to 16 GB. So I would assume that this could be proven using the benchmarking. So what is the ADSYS website? So in the etcd report, there is a benchmark.
Okay, sounds good. It's the performance is the one with the heat maps or the.
That's a good question. it was someone recently. I don't know. We should have one of those should be preferred tool for the benchmarking.
So I will dig out the benchmark you're talking about and post back in the issue that this is what I'm planning to test. If people think more stuff should be tested, just add into that issue. Thank you.
Okay, that's all. Any other last topics or quick questions that we could help answering? Okay. Thanks, everyone. Hope you have a great local time and see you on the next meeting.
Thank you.